Over here at Georgia College and State University. We're in the chemistry lab and we're doing a bit of cleaning up today. So today I'm going to start off with my flask that it's got some blue stuff in it. And in fact, I know this is copper nitrate, or copper 2 nitrate I should say, because it's labeled properly. And here's the first thing we need to learn about cleaning up. Well, second. First thing, proper protective equipment. Side shields or goggles and of course gloves. But the second thing takes place before you start at the lab, or while you're doing it. All your containers must be labeled. If these guys aren't labeled, I have a liquid. Now, copper's pretty distinctive, but some of the other ones, yeah, it's clear, it's colorless. I have no idea what it is. So, you've got to label these guys. Because how you clean up depends a little bit about what's in here. Now, copper is large enough, it's high enough atomic mass that it's what we consider a heavy metal. Generally speaking, things with a mass above that of iron, we're going to have to take a little bit more care of. Of course, different organic compounds as well as other chemicals, you know, we're going to have to deal with those. So, I've got my copper nitrate, and I'm going to have to deal with it. So, over in the hood behind me, I have a series of waste containers. These will be shipped off to professional waste disposal companies. And, well, I have to put it in the right container so it goes to the right waste disposal company. I have copper nitrate. This is an inorganic compound, so I'm going to put this in the inorganic waste, which happens to be this particular container. Yay, that was exciting. Okay, next up, I've still got a bit in here. I'm going to use a little bit of water to clean this out. So, off camera. Some distilled water. Just going to use a little bit on the inside. Give it a swirl. And into the waste. You don't want to go nuts with the water though, because you're making more waste. We are going to have to pay to dispose that stuff. It is important. And well, when it comes to waste, dilution is not what you want to be doing. You're just making more waste. Okay, so I have a flask that's clean-ish. I'm not totally clean. I still got to do a bit more work with this thing. So let's head over to the sink and look at my hands while I clean this critter. Okay, so I'm here at the sink. I've got my flask. I've got myself a beaker brush, and I'm going to put a little bit of soap in this guy. And I'm going to grab some nice tap water. Tap water, very available, very cheap, and hey, we're cleaning. So right now I'm going to start my first wash off with a bit of tap water. And I'm going to scrub this critter and get this nice and good. Now, keep in mind, glass has two sides, so I'm going to wash the outside. Now, my copper nitrate label, that's over here in Sharpie. So the water's not going to take that off, so I'm going to pull in the acetone here in a second. Now, I will point out, the acetone never goes in the sink. Now, I got some soap on here. Let's get this guy rinsed off. And you want to rinse these guys, you know, a lot. Generally speaking, I recommend about 10 times. Of course, you know, look how things are going. But you want to flood it, rinse the outside. Once again, glassware's got two sides. We're trying to make this clean so we don't mess up our experiments. And let's just be honest, we want it to look pretty too. Okay, so I've rinsed that a bunch. Now, tap water has a lot of extra junk in it. So, you know, I don't want to just end with that. So over here, I have some distilled water. Georgia College, we use distilled water. Other colleges might use deionized water. Both of these guys are kind of a medium grade water. Our tap water, that's low grade. Distilled water, that's a medium. You might be working with some high grade or double deionized water, depending on what you're doing with. Now, once again, glassware's got two sides. Now, let's get rid of that label. You always want to delabel your glassware, one, just out of politeness to the other person using it, and two, so we know that this is not copper nitrate anymore. I'm going to take a paper towel, moisten it with a little bit of acetone, and I'm going to wipe it down. Now, I've got myself a wet flask. I've got a couple of things I can do with this guy to get it dry. First approach, I can take the flask and put it on the pegboard. That works great if I'm not in a rush at all. Now, let's say I'm in a rush, and to be honest, in lab, you're probably going to be in a rush because you need to get this glassware back to the stock room before you go home, and you don't really want to be hanging out in the lab for a week or so while the thing air dries. So, grab your acetone, put a little bit of acetone in your flask. Don't go nuts with this stuff, though. Okay, you're going to roll the acetone around the outside. By outside, I mean inside. Goal here, you're replacing the water. Acetone has a much lower boiling point. You're going to be able to evaporate this real easy. Now, you've got acetone. Acetone does not go in the sink. I'm going to go over here and look for my organic waste. By the way, these do move from time to time, so read the labels. Don't just think it's the second one from the right. Although right now it is the second one from the right. Okay. Acetone goes in here. Now, I'm going to take it to the next hood, and we're going to hit this nail. Before anything else, these are compressed air. And so grab the heel and blow out the acetone. Okay, looks like I've got the inside nice and dry. And a little bit of paper towel, and this guy will be beautiful.